Now that we have our sign in and sign up endpoints implemented, we can move on to protecting other existing endpoints, for example, the CRUD user endpoints we generated in previous lessons. To achieve this, we'll create a guard that will check for the presence of a valid JWT as a bearer token. Any protected route handler with this guard will only be invoked if the user has been successfully validated. Alright, so let's head over to our terminals and generate a new guard via nestgguard, and let's place it within IAM, authentication, and put it within a new guards folder, calling it access-token. Let's open up this newly generated file and start by adding the required dependencies. First, let's inject the JWT service into our constructor that we're going to use to decode incoming JWT tokens. For this, we'll also need the JWT configuration again so that we can pass the secret key down to the decode method. Perfect. Before we can validate an incoming JWT token, we first have to extract it from the request object. Depending on what your strategy is, and whether you're sending access tokens as part of the authorization header, as we are now, or you decided to use the HTTP-only cookies approach that we presented in the previous lesson, the implementation here will vary just a little bit. In this lesson, we'll assume that the token will be included in the authorization header, which is generally a very common, widely used pattern. So let's start by declaring a new method and name it extractTokenFromHeader. This method will accept one parameter, which is the platform-specific request object, in our case, Express.js request. Make sure to import the request interface from the Express package. Next, inside of this method, let's grab the token from the authorization header. The reason we use split here is that the bearer token should have the bearer prefix, which we can ignore at this moment. We want the token part that comes right after it. Alright, with this method in place, let's grab a reference to the request object in our canActivate method using the execution context. Note, for GraphQL applications, you'd have to use the wrapper GraphQL execution context here instead. Next up, let's extract the token from the request object using the method we just declared in our class. And in the case the token is not present, let's throw the unauthorized exception error. In case the token is available, let's use the JWT service verifyAsync method to verify and decode it. In order to use await in our method, we also need to align the method signature, flag it as async, and update the return type as it can't contain Boolean and observable Boolean anymore. Since verifyAsync may throw some custom errors like JWT expired that are not auto-recognized by the Nest.js framework, we must wrap it in the try-catch blocks and rethrow an unauthorized exception. Note, to improve debugging experience here, we could log the original message down just for development purposes, or convert it to a user-friendly message and pass it as an argument to the unauthorized exception constructor. Perfect. And lastly, let's assign the decoded payload to the request user property, which is a very common practice in the Node.js community. This way we can access the user object later on in our endpoints or other subsequent guards. However, doing this here without defining the user key as a constant can lead to some unexpected behavior. Let's go ahead and create the im.constants file in the im folder, and inside of it export request_user_key constant, making it equal to the string of user. Now back to our guard, let's use it inside. Let's also temporarily add a console log just to verify how our decoded object looks. Alright, let's save our changes, and before we bind this guard to any routes in our system, let's head over to Insomnia to grab a valid access token. Let's call the sign-in endpoint again and make sure to copy the access token to our clipboard. Next, let's switch back to our IDE, open up the IAM module, and register access token guard globally using a dedicated app_guard token. Note that we could have binded access token guard to individual routes instead of doing this globally, using the use guards decorator. But since it's rather a tedious process, we decided to auto-protect all endpoints we have in our application by default. This is also a recommended best practice as it mitigates the risk of someone forgetting to annotate a newly added endpoint with this guard. Now instead, every new endpoint will automatically become protected. Since there are certain routes from which we want to intentionally skip the authentication requirement, we will implement a new decorator that lets us exclude those routes in the next lesson. Back to our task at hand, let's save all our changes, switch back to Insomnia, and try to hit the coffee's endpoint, the one that was auto-generated by the resource schematic a few lessons ago, just to see what happens. As we can see, we received the 401 error saying that we're unauthorized to access this resource. Great! Now let's click on the Headers tab and add the authorization header so we can send the access token as part of our request. For our key, let's call it authorization with a capital A, and for the value, let's paste our access token prefixed with the bearer string we copied a moment ago. If we click send, we should now see that everything works. Great! We received the "this action returns all coffees" string, which is exactly what our coffees controller route returns. Our guard was able to verify and decode our JWT access token and allowed us access into the application. Excellent. Let's switch back to our IDE real quick just to verify what was logged to the console for our user payload. And there we have it, our decoded user payload that will be passed down with our JWT tokens. As we mentioned earlier, this could be used in other routes, other guards, or anywhere in our application where we might need this user-specific information.